Today's lesson is on performing rotation. So rotation is what, right? We're rotating about a point, which is also called a turn, right? And the center point that we're rotating around is called the center of rotation, right? And generally speaking, right, we've got rays drawn from the center of rotation to a point, right? So maybe it's a point on our triangle, and then we're rotating from there, right, to form that angle of rotation. And then we're going to rehab the ray again with that same point being moved. And on the next slide, it kind of shows it a little bit better. And again, P is our center of rotation. And there's two options here, right? You'll notice they talk about if, and basically it says, right, we're rotating so that an angle of x degrees, whatever that angle of rotation is, maps every point in Q, point Q in the plane to a point Q prime, so that one of the following properties is true, right? One of them is going to be where Q is the center, and then Q would not move. But the other one's going to be where Q isn't the center. This picture is going to follow the one where Q is not the center, right? This top part, Q is not the center of rotation P. Then QP and Q prime P should be the same distance, right? I'm saying this here, this mark here should be the same. And the measure of angle QP, Q prime is x degrees. And generally, we're rotating counterclockwise, right? If Q is the center of rotation, then Q and Q prime is the same. I'm missing my prime there, but the image of Q is Q prime. So, little note, we're going to have some patterns here with our rotation. If 90-degree rotation is, we can go from the pattern of xy to negative yx, what would 180 and 270 degrees be? And if you continue the pattern beyond that, you should get back to your original xy, right? So, right, they're saying we started with xy, and then 90 degrees, rotated it so that it became negative y, x. So basically, the y value switches to the front and times -1, and the x value, or whatever's in front, just fills. So that was 90 degrees. We do it again. This time, now I already have x in the y position. We're going to rotate that up front, multiply it by -1 to get negative x, and then the negative y is just going to fill back into its y position. That would be 180 degrees. Trying one more time for the 270. Again, y position is going to flip to the front, multiply by -1. It already is negative, so that's going to make it positive. And then the negative x flips to the back. And that would be 270 degrees. And again, that final challenge, if we do y minus x with a 90-degree flip, just to see, do we get back to normal? -1 times x is going to be positive x. The positive y flips to the back. And yep, that would be the same as staying the same, or 360 degrees, right? The same as the original. So these are going to be the patterns that you either need to memorize, or if you can memorize the 90-degree pattern and continue to do that multiple times as we just did, then you only have one thing to memorize. Otherwise, there are 3. So this is the same information we just did, but broken down more to piece by piece. Right? So we got 90 degree is, we go from AB to negative BA. 180 degrees goes from AB to negative A, negative B. 270 degrees, which is from AB to B, negative A. And then just kind of having you thinking about it, what do you think the matrices for rotation would be for that, right? Basically, how do we switch from BA, so BA would probably be like this and stay in the same spot, to negative BA, right? This is AB. And so I want my A to be my Y value, X, and my B to be my X value. So that would probably look like that. And then A would be probably like this, to multiply to get that X value to be the same. But we'll see if we're right here on the next slide, and we can continue with 180 and 270 So looking 90 degree, if you like matrix multiplication, you can look at these patterns that should reflect the same idea as AB, again, that would be A, a lot of practice with that, AB to negative AB, negative A negative B. And then clearly we don't need to worry about the 360 degrees, but this one would be B negative A from our origin. So you can use those matrix rotations similar to how we use the reflection, right? If you use the reflection ones, recall that those matrices have to be in front because of how matrix multiplication works, right? Because we couldn't do a 2 by 3 by multiplied by a 2 by 2. Right? This matrix multiplication won't work because these don't match, so they flip the order. They do the rotation matrix first, then by whatever matrix you have for your point. So trapezoid has vertices, negative 3, 2, negative 3, 4, 1, 4, and 2, 2. Find the image matrix for a 180 degrees rotation about the origin. Okay, and then we'll have a graph on the next slide for graphing both of those. So, again, a couple options. I'll show you pattern form. We'll still write the matrix, but we'll show you the pattern method, and we'll show matrix method. So these are my 4 points, EF, GH, in a matrix. And if I need to do 180 degrees, this whole matrix, we need to get multiplied by the 180 degree matrix. 180 degree rotation is going to be like the original, but you just flip your signs, right? So if we did this math, for matrix multiplication, which we'll show you that first, basically this ends up being -1 times -3 plus 0, right? We're just flipping the sign. -1 times the other -3 plus 0, right? Because your top number should just be flipping that +3 to -3. -3 to +3. Again, -3 to +3. +1 to -1. And +2 to -2. And then the bottom one, same thing. 0 times -3 plus -1 times 2. We're just flipping the signs. You could actually multiply it all out and realize that anything that has a 0 is really pointless to write. Right? 0 times -3 isn't going to give you anything in this first row 1 times column 1. But, or sorry, row 2 times column 1. But -1 times 2 will cause that +2 to flip to be negative. So here's my image points for E prime, F prime, G prime, H prime. And again, just like with reflections, my orientation is going to change based on my rotation. So, graphing it. Guess we don't have a graph of that one, so we'll move on. Next, we've got similar trapezoid. EFGH has vertices -5, 1, -1, 4, 4, 4, 4, 1. Now find the image for a 90 degree rotation about the origin, and then graph the pre-image and image. Now we do have a graph for this one, but this time we will show pattern. Right? So with the pattern method, it has to be what is the pattern for 90 degrees. Right? 90 degrees is the pattern. If we start with AB, we go to -BA. And so I'm going to write my 4 points, EFGH out here, and just follow the pattern. We're going from XY to -YX is the other way to think about it. That actually might even be more understandable. Right? All the points are going to be XY, and just writing in XY form. But again, E is -5, 1. F is -1, 4, G is 4, 4, and H is 4, 1. And now we're just flipping, right? The 1's going to come to the front and flip its sign. The -5 is going to fill into the back. And that is going to be my new E value, E prime. 4 is going to flip to the front, flip its sign, -1's basically filled. Same thing here. The second 4 flips the sign, flips to the front. And the original 4 in the X value flips. And lastly, 1 flips to the back and becomes -1. 4 fills. And this would be, again, and make sure I prime my image. So now we're going to graph those here. And we've got -1, -5. Sorry, -5, 1. We're going to graph the original first. So there's our first point. There's E, negative 1, 4. There's F. We got 4, 4. G, and then 4, 5. But not a trapezoid. I have a number issue here. Yeah, because 4, 5 is going to be right there. It should be 4, 1. So I got an error on the last page, which will mean that if H is 4, 1, our split is going to be negative 1, 4. Actually, I have that right. I just wrote it down wrong. Okay. Yeah, I've got it right here. I just wrote it down wrong. It's wrong on the notes. So just a heads up on that one for night 4. Said 4 or 5 on the H on my problem. What was that? Okay. And throwing those in, connect the dots. This is our original. And now doing the rotation, right? 90 degrees going this way is going to flip it basically onto itself. So now plugging in my points, negative 1, negative 5. Down here, negative 4, negative 1, negative 4, positive 4. Right. There's negative 4, 4, and then negative 1, 4. What do you know? F and H prime happen to be the same point. That's all right. It should look the same shape, different orientation. Right? There should be congruent shapes to each other. We're not going to check that. Moving on. Quadrilateral ABCD has vertices negative 5, 3, negative 3, 4, negative 2, 2, 5, and negative 1, 3. Try this on your own. Pause the video and see if you can find an image for 270-degree rotation. We'll check if you match. So here is our image points. We need to pause the video to write them all down and match. But basically, the x values flip to the y's and flip their sign because this is a 270 degree. And the y just flips to the front. So this 3, 4, 5, 3 stayed the same. And now there's also a note, I have seen some people who like the matrix organization of the numbers, but instead of doing the multiplication, they just kind of understand the pattern. You can also do that as well. And again, that doesn't mean you have to show the math, but if you're doing the 270-degree rotation, right, I just know that 3, 4, 5, 3 is going to come to the top. And then my negative 5, negative 3, which turn into positive 5, negative 3 turn to positive 3, positive 2 turn to negative 2, and negative 1 turn to positive 1, right? Knowing the pattern, that's another way you can just kind of portray those images happening, the value of the image. So with that in mind, we'll graph the last one, and then we'll get into some trickier math. So graph those points. So not, looks almost triangular, but pretty basic. Quad, and then 270-degree rotation is going to be basically rotating 90 degrees that way, if you want to think about it as that way as well. Plotting our images. There's A prime. B prime right on my D. And then 3, 1. And I think one of my original points here is wrong. Actually, my D value is wrong. It shouldn't be the same point second. I believe it was negative 1, 3. basically had the sliver of a shape for A, B, C, D. Okay. So now I'll continue to have the same sliver, just in quadrant 1 and 4. So there's that. So that's our overlapping D this time. And that wraps up that portion of the lesson. I don't know if these have been in every slide, but basically everything besides dilations are a isometry, right? We should have congruent shapes with what we started with. Kind of mentioned that already. Reflection should be congruent, translation congruent, rotations are congruent. Not proving that, although there are math, kind of again, distance formula proofs for that. But we'll get into kind of some trickies here. We got to determine whether the matrix multiplication represents 90, 180, 270, or 360 degrees. Now, you can treat this as its own problem, like multiply and try to find two pairs such that you can solve for x, solve for y. Or you can just kind of look at the pattern, right? If you look back a couple slides at the different rotation patterns, that was a 0, right? You had 90, 180 was that pattern, and then in 270 was that pattern, right? So looking at this, we know that if there's a 0 here, y must be a 0 as well. So starting off with y equals 0, because our diagonals are generally the same, or one's a 1 and one's a negative, right? And so already by crossing off, like it can't be this one, and it can't be this one, the ones that have ones in the corner, because we had a given 0 in the corner, we're left with either going to be a 0-degree rotation, 360 technically, or a 180, right? So this would be 0, 180, or technically 360. I guess that's one of the options. So just doing the math, right? X times 3 plus 0 times y minus 6, which is 0 anyway, right? Equals x minus 2. So this gives us 3x is x minus 2, minus x from both sides, divide by 2. 2x is minus 2, so x is minus 1. And that gives us this negative 1, 0, negative 1 pattern. Right, that's our, that's what this matrix will be, and that is 180 degrees. So you don't necessarily need to solve for both to find the answer, but in this case, that is our answer to that one. And you can always pause if you need to catch up with the notes. Moving on. Same idea, a little more difficult with these. I only see a 0 in the corner, so kind of copy pasting what we just wrote down. It's not going to be this one, which is the 360. Right? It's not going to be that. And it's not going to be the 180 either that we just did, because we have a 0 in the corner. So it's either going to be 90 degrees or the opposite of that, which is 270, right? So we got 270 or 90. So knowing that this is 0 and this is 0, y plus 1 equals 0 gives us y is minus 1. So now this one's minus 1. Which of our two options is it? Only one has a minus 1 in the corner. It's 270 degrees. So we didn't even need to multiply with that one. That doesn't mean that it couldn't have helped you if you solved it a different way. But just looking at the patterns that we have to have zeros in one set of corners, and that solved it for us. It didn't say you had to solve for x and y. It just said determine whether it makes it. And that wraps up today's lesson. The homework is posted on Classroom. Have a great one.